السلام عليكم ورحمة الله وبركاته. It's my pleasure, me Mahfoud al-Nasri, to present to you this paper entitled Creativity Skills and Project-Based Learning Integrated STEM on Chemistry subject. Recently, unfamiliar challenges appeared, especially in health and medicine industry sector and pollution problems. To confront it, there's a need for a generation that can create original solutions to solve it. Many researchers approve that STEM project-based learning is one of the most crucial ways to foster creativity. Domenici viewed chemistry as the central science due to its close tie to other scientific disciplines, and it's utilized in creativity by using knowledge of chemical structures to create new ones to solve problems. However, students try to avoid choosing chemistry as a major because they have trouble recognizing submicroscopic details, which cause them misunderstand the chemical concepts. Therefore, researchers need to pay close attention on how to foster creativity in chemistry using multi-level model as identified by Alex Johnston, so the students can form chemical concepts and engaging them in real-world activities that related to their past experience and emotions and connected with the concepts so they can foster imagination and enhance creativity. Despite many studies conducted in domains of science, little is none are conducted in chemistry. This systematic review will provide a better understanding on this. Prisma 2020 flowchart and checklist is used for systematically review articles from three well-known databases, which are Scopus, Web of Science, and Google Scholar. To identify these articles, it must be published from year 2016 to 2022 in English, and we choose only the empirical publications that focus on STEM project-based learning in chemistry to develop creativity. These articles then were screened and evaluated for eligibility using 7 criteria with 4 scoring scales. Then we followed 27 points checklist. After all these processes, the accepted article became 18 articles. To analyze their findings, we used theme analysis method. As can be seen from the pie chart, the most significant publications was in 2020, and most of the publications done by Indonesian researchers. There are only 2 publications done by Malaysian researchers. For the empirical publications, the 3 designs were equaled by 6 articles. There are 2 articles of the reviewed articles compared between STEM project-based learning and project-based learning only in examining scientific creativity or science processes and creativity skills. The results showed that STEM project-based learning was better than project-based learning only in improving creativity and enable students to be involved and create innovative solutions. Some articles considered creativity as part of modern skills, such as entrepreneurial characteristics and 21st century skills. The studies that focused on entrepreneurial characteristics identified and marked creativity as the ability to create products with added value to increase the sales rate. And some researchers advised to develop an entrepreneur character through digital branding. Other studies differed in investigating 21st century skills, but they couldn't undervalue creativity. And they advised to investigate the impact of STEM project-based learning on media and technology literacy. Some of the reviewed studies paid all the attention on examining creativity domains. The studies that investigated cognitive creativity domains use scales from Torrance 1970 or Torrance 2008. Our review of their findings revealed that originality scale is the least skill that improved by STEM project-based learning. So the researchers advised to involve students in programs that can increase their confidence in creating original ideas. In contrast, the other studies investigate emotional creativity skills to measure creativity tendency using William Creativity Assessment Packet. While Law and other measured both cognitive and emotional domains, unexpectedly, only the cognitive domains improved by STEM project-based learning. That's why they recommended to extend the class period and involve students in daily life activities to foster imagination for creativity. Some researchers support specialization in creativity, like Ho and Eddy, who stated that general creativity assessments will not do for assessing scientific originality. So and Ambo conducted two articles or studies through implementing STEM project-based cooperative learning to enhance scientific creativity for fifth graders. And their findings showed the significant beneficial effect on scientific creativity, and they suggest to conduct different instructional method with the students from after post-primary education. 61% of the reviewed articles implemented chemistry topic themes. 63.6% of them targeted secondary school students to prepare them for higher education and future employment opportunities, while the remained 36.4% of the articles targeted pre-service chemistry teachers because they must be enabled in creativity skills so they can transfer and contextualize methods to help students becoming proficient employees and entrepreneurs. Nonetheless, there is a shortage of researchers that focus on how to solve the problem of difficulty in learning chemistry. Our findings reveal that using STEM project-based learning has positive, significant impact on creativity. There is a need for more research that investigate the impact of chemistry STEM project-based learning on scientific creativity. And we suggest to involve students in long-term multi-project STEM project-based learning programs. Finally, the researchers thanks UTM University for allowing us to access the database engines, and great thanks from me to Prof. Johari for his academic guidance. Thank you so much.